and today we're going to talk about types of heat exchangers and design performances. Heat exchangers are a big part in our daily life. We use them pretty much every day. We can see them in many engineering projects such as the refrigerator or the AC or air conditioning. Or sometimes when we turn on that machine which uses the same cycle, the same concept of a heat exchanger to warm up the room. Well, all that began with the first known heat exchangers for homes were simply a rock placed in a fire. The rock would store the heat from that fire and could then be moved inside of a hut or a small tent to warm the interior without fear of burning it down. The heat that was being lost from the fire was captured by the heat transfer surface, which is again the rock, and used to heat up inside the residence. The same method of thought led to development of the hot water bottle. As you can see in the middle, the red hot water bottle. Well, the heat exchanger is a device that is used to transfer thermal energy, enthalpy, or simply heat between two or more fluids. A fluid can mean two things, either a liquid or a gas, between a solid surface and a fluid, or between solid particles and a fluid at different temperatures and in thermal contact. They are widely used in space heating, refrigeration, air conditioning, and petrochemical plants. As you can see, refrigerators and air conditioners, we use them pretty much every single day. The classic example of a heat exchanger is found in an internal combustion engine, in which a circulating fluid known as engine coolant flows through the radiator coils and air flows past the coils. The radiator, we use it every day in our car. It's one of the most important components of the car, which is the radiator. A heat exchanger. What is a heat exchanger? Well, it's a closed loop between two liquids, and there's a solid surface in between. The process of a heat exchange between two fluids are at different temperatures and separated by a solid wall occurs in many engineering projects, such as the air conditioner. The device used to implement this exchange is termed a heat exchanger. That means whatever device that exchange heat between two fluids can be an heat exchanger. And specific application may be found in space heating and air conditioning and chemical processing. Let's talk about the types of heat exchanger after we know what are the heat exchangers and how does it work. The heat exchanger we talked about is between two liquids at different temperatures. So how do they flow? How do the liquid or gas flow through that heat transfer or heat exchanger? Heat exchangers are typically classified according to flow arrangement and type of construction. The simplest heat exchanger is one of which the hot and cold fluids move in the same or opposite direction in concentric tube construction. So the types are categorized of how do the fluids flow inside. How do they move from one point to another. So we have here a simple graph of hot liquid or hot gas going through the same direction as the cold liquid or cold gas, which we call the parallel flow. And the opposite end, we have the counterflow, which one fluid moves in a certain direction and the other one moves in the opposite direction. Heat exchangers are classified into concentric tube heat exchanger, parallel flow, and counterflow. Shell and tube heat exchangers. We're going to talk specifically about the shell and tube heat exchangers in the next slide. Concentric tube heat exchanger, parallel flow, and counterflow. So heat exchangers are typically classified according to flow arrangement and type of construction. The simplest heat exchanger is one of which the hot and the cold fluids move in the same opposite direction in a concentric tube. In the parallel flow arrangement of figure 1, the hot and cold fluids enter the same end, the flow in the same direction and leave at the same end. In counterflow arrangement of figure 1, the fluids enter the opposite ends, flow in opposite direction, and leave at the opposite ends. Well, it's self-explanatory, but as you can see in figure 1, the input of the cold and hot fluid are in the same end, as you can see here, and the output of the cold and hot fluid is at the opposite end, which is totally different in the counterflow, which has the hot input next to the cold output, and vice versa. The shell and tube heat exchangers. It is called a shell and tube exchanger because they manufacture it as two shells, and in between are many tubes for the liquid to go through. Another common configuration is the shell and tube heat exchanger. Specific forms differ according to the number of shell and tube passes. The simplest form, which involves single tube and shell passes. Baffles are usually installed to increase the convection coefficient of shell side fluid by inducing the turbulence and cross-flow velocity components relative to the tubes. Well, this is a simple shell and tube heat exchanger. As you can see in the blue, these called the shells, and inside are two components, which is baffles and the actual tubes. We have 5 or sometimes 4 outputs and inputs accordingly to the. We can see the water, the cool water, the cold one, or any fluid goes through the shell and through the tubes. That, as you can see, there's a solid surface that forces the cold water to go inside these small tubes inside. And when it comes to the opposite end of the shell, it goes up and back again to the opposite direction of the flow, the original flow. And while this is taking part, we put steam or a different type or hot water inside that input, which goes through baffles. As you can see, these are half circles, which is the hot water or steam goes through them. With increasing the baffles increases the coefficient of the heat exchanger. So the shell and tube heat exchangers are mainly where the hot water comes in. The solid surface forces that water to go through the tubes to the other shell. The other shell is filled up and goes to the upper side of the tubes and goes back again to the water outlet. While all of that is happening, we insert steam or a different temperature water inside the input, and it goes through the baffles inside which these two liquids exchange thermal energy, and that is the shell and tube heat exchange. So what are the advantages and disadvantages of shell and tube heat exchangers? Well, the advantages are it can be used in systems with higher operating temperatures and pressures. Tube leaks are easily located and plugged since pressure test is comparatively easy. The cleaning and maintenance is a disadvantage, which is difficult since the tube cooler requires enough clearance at one end to remove the tube nest. It requires more space in comparison to plate coolers. So how do we improve the performance of those heat exchangers? How do you improve the efficiency of heat exchangers? The fluid can flow in perpendicular directions, which is known as cross-flow arrangement. We talked about counterflow and parallel flow, and this is the perpendicular direction, which we call cross-flow. The two main types are finned and unfinned tubulars. With a finned tubular heat exchanger, both fluids are unmixed. The one between the fins is guided in the direction transfers to the tube flow direction. In the unfinned exchanger, heat can be exchanged in all directions and fluid can mix. So, what are the comparisons between a finned tube and unfinned tube? The finned tube increases the rate of heat transfer to or from the environment by increasing convection. The amount of conduction, convection, or radiation an object determines the amount of heat it transfers. On the other hand, the unfinned tube increasing the temperature gradient between the object and the environment. Increasing the surface area of the object increases the heat transfer. All in all, heat exchangers are classified into two categories, each having its own pros and cons. As discussed above, heat exchangers are used to transfer enthalpy or heat between two fluids. Shell and tube heat exchangers are less expensive plate type coolers, which make them useful. Heat exchangers are very important for industries as they are frequently used in air conditioning, space heating, and power production. And that is all, and thank you for listening.